Replacing a high-pressure pump can cost over $1,000, and a new RO membrane runs several $100. But actually decides how long these expensive parts last? It's usually this little guy right here, the pre-filter at the very front of your system. Many captains deal with burned-out pumps or system errors. But the crazy part? It's usually not because the filter is cheap, but because they're using the wrong filter for the job. Hey guys, I'm Jason. Welcome back to Pure Ocean Marine. These are the most common water filters today. We'll trace their evolution, showing their pros, cons, and ideal uses with real-world examples. Just looking at the outside, you can't really tell how water flows through them when they get hit with salty, algae-filled ocean water. So to truly understand their underlying logic, let's take a direct look at the cross-sections. First up is the melt-blown PP cotton filter. Its purpose is to treat relatively clean city tap water using depth filtration. It works like a 3D sponge. As water flows through, impurities are absorbed into its internal channels, filtering the water. But what happens if you drop this in the ocean? Natural seawater is full of microalgae and plankton. That sticky stuff will instantly seal up this smooth surface. Once it's clogged, water can't get in, causing a massive pressure drop. Your feed pump gets starved of water instantly, leading to running dry. And boom, that's how you fry a $1,000 pump. These two PP filters you see here, even with different surface designs, actually suffer from the exact same flaw. To fight that pressure drop, the industry eventually came up with this, the deep-grooved PP filter. The grooves give it more surface area and make it structurally stronger. Yeah, it lasts a bit longer, but the core flaw of depth filtration is still there. Next is the string-wound filter. This guy is built for groundwater packed with heavy sediment. It's made by crisscrossing coarse yarn around a core. But in a watermaker, the constant high-pressure flow creates a huge risk: fiber shedding. Look at this. If these tiny loose threads make it into your high-pressure ceramic plunger pump, they'll cause irreversible scratching. So, with how brutal the ocean environment is, none of these are ideal. What structure actually works best for a marine watermaker? The answer is a pleated filter, which uses surface filtration. But if you just search for pleated filters online, you'll probably end up with one of these, a microporous pleated PP filter with a hard plastic shell. These are designed for ultra-pure drinking water or labs. They are awesome for city tap water. The massive surface area traps dirt perfectly, blocking rust and sediment. But throw this in the ocean? Those super dense micropores meet marine slime and algae, and just like the cotton filters, they blind over almost instantly. They completely lose water flow, and that plastic outer shell blocks nearly 40% of the actual water intake area. You might be thinking, why not just cut off that outer skeleton? Well, the problem is the PP material inside is way too soft. Without that external cage for support, it just collapses under pressure. So our final answer is this seemingly basic, frameless, pleated PET filter. It also relies on surface filtration. If you flatten out these pleats, you'll see the actual filtration area is 5 to 10 times bigger than a standard smooth cylinder. In fluid dynamics, the larger the surface area, the more dispersed the water flow, which results in lower resistance. Dirt and algae are spread evenly across a massive surface area, while the inside stays completely clear. This not only multiplies the dirt holding capacity, but it keeps the system's water resistance to an absolute minimum. You can see here, even though they're both PET filters, the pleat density from different manufacturers varies a lot. For us, a higher pleat density equals a larger filtration area, which means a much longer service life on your boat. We thought the story ended there, until we found this specific pleated P filter from a Taiwanese manufacturer. Its stiffness is really close to the PET filter next to it, maybe even stiffer. A special manufacturing process allows it to hold its shape perfectly without needing an outer plastic cage, just like the PET ones. And as you can see, its pleat density is the highest among all three frameless filters here. So, based purely on watermaker performance, this one is hands down the best choice on the table. However, there's a catch. Its price is 2 to 3 times higher than the standard PET and PP filters. So, from a value for money standpoint, the standard PET pleated filter is still the absolute sweet spot for most sailors. The takeaway? There's no such thing as a perfect filter. They only perform their best when you match them to the right job. For city tap water, a cheap PP cotton filter is the king of value, and the caged pleated PP is top tier. In wastewater treatment, string-wound filter cartridges are the optimal choice. But in the ocean, with all its complex microbes and high salinity, your watermaker needs a fully open intake flow, minimal resistance, and a massive dirt holding capacity. That's exactly why, when engineering pure ocean marine watermakers, we chose to eat the extra parts cost and strictly use these high-flow pleated filters. As engineers, we don't just consider how clean the treated water is, but also the absolute stability and safety of the entire system when used offshore. Alright, that's it. We're Pure Ocean Marine, offering specialized marine watermakers for freshwater freedom. As always, if you enjoyed this technical deep dive, hit that subscribe button. We'll see you out on the water. Catch you in the next one.